In other tutorials, we have seen that here in Explore submodule, we have a couple of tools for segmenting different anatomies, teeth, airways, and jaws. What if we would like to segment, that is, to extract as separate objects and to know the volumes of other anatomies as well? For that purpose, we have two more tools here under annotation tools. So firstly, we have this region grow tool that we're going to cover in this tutorial, and this we can use for segmenting, assisted by the software, anatomies that have a clear difference in terms of grayscale values with the surrounding anatomy. This other tool then, this manual segmentation, we can then use for segmenting anatomies that don't have that clear difference with the surrounding tissue, so that the software is not able to recognize them well. So let's then focus on this region grow tool. Let's see how this works. So firstly, like we see, it's disabled at the moment, and that is because in order to make it working, we either need to use this measure cube or measure ellipsoid tool. So we would need to make a cube or ellipsoid that encloses the anatomy that we're going to segment. So this would be the first step to do here. So if we make here a simple case of extracting an airway, for which we could naturally also use this dedicated tool. But let's use this as an example, because this is a simple case. We can clearly see the anatomy that we're interested in. So firstly, we can adjust these slices so that we have a good view on the anatomy that we're going to segment. And then for the airway, we could activate this measure cube tool. And then we're going to draw here a cube, keeping our left mouse button down. We're going to draw a cube that, like I said, encloses the anatomy of interest. And in the other views, well, when we don't have this move rotate volume activated, we can grab this cube and we can adjust it so that we make sure that the anatomy of interest is inside. So we could activate this cube by clicking on it, clicking on the border, and we could also drag on these small rectangles on the corners. So like we see now here, this is like a normal cube. So here we can see the volume of this cube now, but naturally we're interested in a smaller volume, the airway that is inside it. So let's quickly check also here in the axial view that our airway is inside the cube. And also in the coronal view. So when we have adjusted the cube, let's then one more time activate it by clicking on it, so that our region grow tool now turns active and we can open it. So here in this dialog, firstly, we have some presets for different types of anatomies. So here in this case, we are actually going to segment an air cavity, so we can leave it like that. But here in the drop down, we could also see other types of anatomies. The threshold slider is set by default to 300. And what does this threshold mean? It means that in the next step, we're going to select a seed point here inside the anatomy that we're going to segment. So somewhere here in the middle of the airway. And like we see there on the right side lower corner, the Hounsfield unit value, that is the relative tissue density here, is something around minus 800 or so. And so when we click here a point and select that as seed point, in the actual segmentation process, the software will use this 300 as a threshold in determining what everything will be included in the segmentation. So if we start here somewhere at the value minus 800 or so, the segmentation will start there, and it will continue all the way, including all the voxels, that are within this range. So they are either 300 smaller or bigger than this initial seed point. So basically, if we hit here somewhere on the border of the airway and the surrounding soft tissue in a value that is minus 500 something, that's where the segmentation knows to stop. And also the borders of this cube work as borders for the segmentation, so it will also stop here. So that's why we needed to enclose the anatomy inside this cube. So also these borders will stop the segmentation, as well as a big enough difference in the grayscale values here. With these controls, we can determine what color our segmentation will have. Naturally, we can also change that later. So let's now try with these values that are preset. So like said, we'll select a seed point here in the middle of the anatomy that we're interested in segmenting. And let's start the segmentation process with that. So after the segmentation process has finished, we can see here in the 3D rendered view the airway extracted and colored, and also here on the slice views. And next to this box, we can now see the volume of this airway segmented, so not the volume of the whole cube like previously. Now, if we would like to modify our segmentation, we can activate the cube. So also, if we would have closed this and this wouldn't be active anymore, we would need to reactivate this cube around it. And we would then reopen the tool in order to get this dialog here. So let's see then a couple of adjustments that we could make. So firstly, we could adjust this threshold. So like explained earlier, this threshold here determines which all voxels will be included in the segmentation. So if we would see here on the slice views, naturally, we could also maximize the slice view in order to see it better. But if we would see that the segmentation finishes a little bit too soon, that is, it doesn't take into account all the voxels on the border, we might want to increase the threshold so that it takes into account the voxels with a little bit higher Hounsfield unit value here on the border as well. And naturally, instead, if we would see that this segmentation is partly inside the soft tissue and we would like it to be smaller, to finish here on the border without flowing into the soft tissue, we could also adjust this threshold smaller. So then this segmentation would take more strictly into account just the voxels that are closer to this value, this seed point. Besides the threshold adjustment, we could naturally here also change the color, or then one option is also to change the segmentation as colored by area. So then the segmentation result would be colored according to the cross-sectional area at each point. So then it would make the more narrow parts red and the wider parts purple. Then also we have these advanced options. Maybe there's no need to touch these in normal segmentation processes. So these advanced options are actually modified a little bit also by the preset selected. So now that we have air cavity, we actually have this second option selected here. So it's definitely taking into account all the voxels that have a lower value than our seed points, naturally, because they are definitely part of the airway based on their Hounsfield unit value. If instead we would be segmenting bone, for example, we have this selected automatically, so we would include all the higher Hounsfield unit values in the segmentation. Then we also have some pre-smoothing or post-smoothing of the segmentation result, so that would maybe remove some single voxels so that the segmentation result would appear smoother. And finally, we have also here this local threshold that might improve the segmentation result on the border of the segmentation. So this would this threshold here would still refine the segmentation somewhere where the segmentation is finishing in those voxels. So it will still adjust what all voxels will be included in the segmentation just around those voxels on the border. So if you wouldn't manage to include all the anatomy here in the segmentation that you would like to have there, maybe you could still try playing with this local threshold. But now that we have modified these settings a little bit, maybe I'll also increase the threshold a bit. We can then just click here on redo in order to calculate the new segmentation based on these modified values. So now we see recalculated segmentation. Let's check it here in the 3D rendered view. So like we see now the airway is also colored. Here the difference between this and this tool that is dedicated for extracting airways is that these cross-sectional slices are horizontal, whereas here with the airway extraction tool they would be perpendicular to the curved spline with which we define the airway. So maybe with this tool we get a little bit more accurate region areas because they take into account the curvature of the airway. So we can naturally then, besides the volume, we can also see the region area of the segmented anatomy on each slice here beside the cube or the ellipsoid if we would have used that instead. And naturally, this made segmentation we can remove by using this box and the trash can icon here. So we would delete it just like any other annotation.